Hey everyone, welcome back to the channel. In today's video, we are going to create a random enemy patrol AI in Unity using the NavMesh system. By the end of this video, you will have an enemy that automatically walks around your environment by choosing random walkable locations on the NavMesh. The best part is that we won't create a single patrol point manually. Unity will handle that for us. Let us first take a look at the final result. As you can see, our enemy keeps walking around the environment whenever it reaches one destination. It automatically selects another random location and continues patrolling forever. This technique is useful in games where you don't want your enemy to follow the exact same path every time. Instead, the movement feels much more dynamic because the destination changes automatically. Now, before we start writing any code, let's understand how this is going to work. Normally, when creating a patrol system, many developers create multiple empty game objects and use them as patrol points. The enemy moves to a point A, then point B, then point C, and finally starts again from point A. This approach works perfectly fine. But imagine you have a very large map. Creating dozens of patrol points manually becomes time consuming. Instead, Unity already knows every walkable location after we bake the NavMesh. So rather than creating our own patrol points, we will simply ask Unity to give us one random walkable position. The enemy moves there. Once it reaches that location, we will ask Unity for another random position. The result is very simple. Random patrol system with only a few lines of code. Now that we understand the idea, let's build it. I am starting with a new 3D scene. The first we need is some ground. So I will right click inside the hierarchy, go to the 3D object and create a plane. I will rename this plane to ground. This will be the surface where our enemy walks. Now let's create the enemy. Again I will right click inside the hierarchy, go to 3D object and create a cube. I will rename this cube to enemy. Since this tutorial is focused on AI, I will simply using a cube. If you are making your own game, you can replace it with any character model later. Now I will slightly move the capsule upward so it's standing on the top of the ground. Our basic scene setup is now complete. But if I press play, nothing happens. That is because our enemy doesn't know where it is allowed to walk. For that we need something called a NavMesh. So what exactly is a NavMesh? NavMesh stands for navigation mesh. You can think of it as an invisible map that Unity creates for AI characters. Instead of checking every object every frame, Unity first analyzes the environment and marks all the places where an AI is allowed to walk. Whenever we tell an enemy to move somewhere, it doesn't simply move in a straight line. Instead, Unity checks this navigation map, calculates the best possible path and moves the enemy along that path. This saves us from writing complicated pathfinding codes ourselves. Now let's create that navigation map. Select the ground object, click add component, search for NavMesh surface. If you don't see this component, make sure you have installed the AI navigation package from the package manager. Once the component is added, simply click bake. As soon as the baking process is complete, you will notice that ground turns blue. This blue area represents the NavMesh. Anywhere you see blue is an area where our enemy can walk. If the area isn't blue, the enemy won't be able to move there. Now your environment is ready. Next, let's prepare our enemy. Select the enemy object, click add component, search for NavMesh agent and add it. The NavMesh agent is responsible for moving our enemy. Whenever we give it a destination, Unity automatically calculates the shortest path and moves the enemy there. You will also notice several properties like speed, angular speed, acceleration and stopping distance. We will keep the default values for now and come back to these after our AI starts moving. Now it is finally time to write some code. Inside the project window, I will create a new C# script. I will name it random patrol. Now I will attach the script to the enemy object. Let's open it. The first thing we need is the AI namespace. So above the class I am going to add using unityengine.ai. Since we are making with Unity's navigation system, this namespace gives us access to classes like NavMesh and NavMesh Agent. Without it, Unity won't recognize any of the navigation related classes that we are about to use. Now inside our class, the first thing we need is reference to the NavMesh Agent. So I will write NavMesh Agent, NavMesh Agent. Let's understand why we need this. Right now our script has no way of communicating with the NavMesh agent. Before we can call the enemy where to move, we first need a reference to that component. That is exactly what this variable is for. At the moment it's just an empty reference. We will assign the actual NavMesh agent in a moment. Now let's move into the start method. Void start. The start method runs only once when the game begins. It is commonly used to initialize variables and prepare everything before gameplay starts. Inside start I am going to write NavMesh agent equal to get component NavMesh agent. This is one of the most useful functions in Unity. Let's understand what it is doing. Every game object can have multiple components attached to it. Our enemy currently has a transform component and an NavMesh agent and this random patrol script. The get component function searches for the current game object for a component of the type we specify. In our case, we are asking Unity to find the NavMesh agent attached to this enemy. Once Unity finds it, it returns that component. We are then storing it inside our NavMesh variable. Now, whenever we use NavMesh agent in our script, we are directly communicating with the NavMesh agent attached to the enemy. Now, let's move into the update method. Unlike start, the update method runs every single frame. This makes it the perfect place to continuously check whether the enemy has reached its destination or not. Inside update, I am going to write this condition. If not NavMesh agent is pathfinding and NavMesh agent remaining distance less than 0.5f, just random patrol. This entire condition decides when the enemy should choose a new destination. Let's break it down. The first part is not NavMesh agent.pathfinding. Whenever we assign a destination to the NavMesh agent, Unity needs a small amount of time to calculate the path. While it is doing that, pathfinding becomes true. We don't want to give the enemy another destination while Unity is still calculating the current one. That is why we use the exclamation mark. The exclamation mark means not. So this condition becomes true only after Unity has finished calculating the path. The second path is NavMesh agent.remaining distance less than 0.5. The remaining distance properly tells us how far the enemy is from its current destination. As the enemy walks, this value keeps getting smaller. Once the remaining distance less than a half unit, we can safely assume the enemy has reached its destination. Only when both these conditions are true do we call the random patrolling function again. This allows the enemy to continuously patrol from one random location to another. Now let's write the most important function in this entire tutorial. The function is responsible for choosing a random location and telling our enemy to move there. So below the update method, I am going to create a new function, public void random patrolling. The purpose of this function is very simple. Whenever we call this function, it should find a random walkable location and send our enemy there. Now the question is, how does Unity know which position are actually walkable? Remember, a few minutes ago we baked our NavMesh. During that baking process, Unity analyzed our entire scene and created a navigation mesh. Instead of storing that navigation mesh as one long resource, Unity actually divides it into thousands of very small triangles. You usually didn't notice this because Unity hides it from us, but internally, that is how the NavMesh is stored. Now every triangle has 3 corner points. Those corner points are called vertices. You can think of them as positions spread all across the walkable area. If Unity can give us access to those vertices, that we can simply choose one randomly. And that is exactly what we are going to do. Inside the function, I will write this line. NavMesh triangulation NavMesh equal to NavMesh.CalculateTriangulation. Let's understand this carefully. On the left side, we are creating a variable called NavMesh. It is the type of navigation triangulation. This is a class provided by Unity that stores information about the baked mesh. Now look at the right side, NavMesh.CalculateTriangulation. This function asks Unity, give me the complete triangulation data of the baked NavMesh. Unity then returns all that information. That includes the triangles and most importantly for us, all of the vertices that make up the walkable area. So after executing this line, the NavMesh variable contains information about every walkable position that Unity generated during baking. Now that we have access to those vertices, the next step is choosing one randomly. So let's write another line. Int random index equal to random.range of 0, NavMesh.vertices.length. Let's understand what's happening here. First, we are creating an integer variable called random index. This variable will store a random number. To generate that number, we are using random.range. The first value is 0. That means the random number starts from the first element of the array. The second value is NavMesh.vertices.length. Let's break that down. The vertices properly contains all the vertices that Unity generated while making the NavMesh. And length tells us how many vertices exist inside that array. For example, imagine Unity generated 800 vertices. Then length would be 800. So random.range generates a random number somewhere between 0 and 799. Every time this line runs, we get a completely different index. That means we will select a different vertex almost every time. Now that we have a random index, we can finally tell our enemy where to move. So let's write the final line. NavMesh agent.set destination of NavMesh.vertices of random index. This line is actually very simple once you understand it. First, NavMesh.vertices of random index uses the random number we generated to access one random vertex from the NavMesh. Remember, every one of these vertices is a valid walkable position. So we are simply selecting one of them. Next comes set destination. This is a function provided by the NavMesh agent. Its job is to tell the enemy where it should move. As soon as this function is called, Unity automatically calculates the shortest possible path. then the NavMesh agent starts moving the enemy toward that position. The best part is that we don't have to write any movement code ourselves. Unity handles all of that automatically. Now let's think about what happens when the game starts. Inside start, we call random patrolling. That immediately selects one random destination. The enemy starts moving while the enemy is walking. The enemy starts moving. While the enemy is walking, update keeps running every frame. Eventually, the enemy reaches its destination. At that moment, this condition becomes true. Since the condition is true, we call random patrolling again. A new random vertex is selected. The destination changes, the enemy starts walking again. This process repeats forever. So with this just a few lines of code, we have created a complete random patrol system. Now let's save the script and go back to the Unity, press the play button. You will immediately notice that the enemy starts walking to a random location. Once it reaches that position, it automatically chooses another destination, then another and another. Because every destination is selected randomly from the baked image, the enemy keeps exploring different parts of the environment instead of following a fixed path. Now let's quickly adjust one setting before we finish. Select the enemy object, then look at the NavMesh agent component. The main property we will use for this tutorial is speed. The speed value controls how fast our enemy moves from one destination to another. If we increase the speed value, the enemy patrols much faster. If you decrease it, the enemy moves more slower. I am going to increase it a little so that movement looks better while testing. You can always experiment with this value later depending on the type of the game you are making. As you can see, the enemy is still choosing random locations, but now it's moving at the new speed we selected. And that's it for this video. And if you found this video useful, just stay tuned to our channel.